4. No, we're not playing golf. We're just doing some math. Most of you recognize that exclamation point as a math symbol, and we read that as factorial. So the definition for factorial says that if n is a positive integer, so we're only dealing with positive integers, then n factorial is defined as n times 1 less than n times 2 less than n times 3 less than n, etc., all the way down to 3 times 2 times 1. So basically, n factorial means we're multiplying every number from 1 up through that number and then getting a product for that. So for example, oh, by the way, IB doesn't use a dot for multiplication, so even though I'm writing dots a lot of the times in my examples, IB always uses an X. They reserve a dot for other things. One of the uses is in their vectors unit when we're talking about dot product. So don't let that confuse you in the text. It's okay on homework to use dots, but on an IB exam you want to use an X. Okay, so evaluate 5 factorial. So according to how we define this, that simply means 5 times 1 less than 5 times 2 less than 5, etc. Keep going all the way down to 1. So that's going to be 6, 30, 120. And that's it. How about something a little more complicated? Let's do 10 factorial divided by 7 factorial. Well, 10 factorial is 10 times 8 times 9 times 7, 6, 5, 4, 3, 2, 1. And in the denominator, notice the placement of where I'm writing this. 7, 6, 5, 4, 3, 2, 1, all being multiplied. And now notice in a fraction, if everything's being multiplied, you can cancel common factors. So 7, let's use a different color. 7 divided by 7 is 1, 6 divided by 6 is 1, 1, 1, 1, 1, 1. Multiplying all that stuff times 1 is just going to be itself. So our final answer will be 10 times 9 times 8, which is 720. Now you can do factorials on your calculator, but why do we even need to grab the calculator and waste the energy on that? After a while you start to do this, you won't have to write out the entire factorial because you'll realize, because you've done enough canceling, oh, well the 7 factorial in the denominator is going to cancel with a lot of what I would have when I write out 10 factorial, and so that's only going to leave me a 10, 9, and 8 that are not canceled out, and then you get your answer that way. Let's look at another example. How about 8 factorial divided by 5 factorial times 3 factorial? Well, let's write it out just to make sure that we see all the cancellations. In the denominator, remember, factorial means we're multiplying. And then times 3 factorial, we just keep going, 3 times 2 times 1. And so now I can cancel all of those, 5, 4, 3, 2, 1. And then 3 times 2 is 6, and that can cancel the 6 there. So all I'm left with is 8 times 7 on top over 1. So 56 is my final answer. So pretty easy, pretty straightforward once you get the hang of it. So what if we get a little more theoretical? Instead of using specific numbers, let's simplify n plus 1 quantity factorial divided by n times the quantity n minus 1 factorial. All right, so let's start writing this out. What's n plus 1 factorial? Well, it's n plus 1 times 1 less than that. So if you subtract 1 from n plus 1, you'll just have n, times 1 less than that, which would be n minus 1. And you keep going, n minus 2, n minus 3, etc. Keep going, and eventually you'll get down to 1. Now in the denominator, the n doesn't have a factorial after it. You can't take this factorial and distribute it like a number. So the factorial only applies to the quantity n minus 1. So let's start with the n. So we have n. And now times n minus 1 factorial. So that means n minus 1 times 1 less than that, which is n minus 1 minus 1, or n minus 2, times 1 less than that, etc. And eventually we'll get down to 1. Now notice we have a lot of things in common that we can simplify. So the n minus 1 factorial will cancel with all of these and everything in between that I didn't write. And then we also have an n down here which would cancel with that n. So after all of this work, the only thing left is an n plus 1 in the numerator over 1. So that's our final answer. Let's try another one. Oh, let me back up for a second. And one thing I do want to mention about this. You may have noticed that n times n minus 1 factorial, that really is the same as just saying n factorial. For example, if I wrote 9 times 8 factorial, well, that's really the same as 9 factorial. So you can think of this as splitting up the 9 factorial, because when you write it out, if I can fit it in, you could group this and say, oh, that's 8 factorial, and then times 9. Similarly, I could say, I could think of, let's say, 6 factorial as 6, 5, 4, 3, 2, 1. And I could say, oh, that's really the same as 6 times 5 times 4 factorial. So sometimes it helps to visualize that you can actually think of these factorials and group them in different ways. All right, back to the next question. Let's expand 2n factorial. Now, when you think of order of operations way back before algebra even, there were a certain order of how you do things. So this factorial symbol has precedence over multiplication. So we have 2, and then times n, and then factorial. So the factorial is going to go first, and that's going to be grouped with what's right in front of it. So the factorial only applies to the n. It doesn't apply to the 2. So if you were thinking of it as this, then the answer would be 2n times 1 less than that, times 2 less than that, etc., all the way down to 1. But because I didn't have grouping symbols here, the factorial only applies to the n. So when I expand this, I'm really going to get 2, and then I'm going to start doing n factorial. And usually, I know the question is, well, how many do I have to write before I can do ... And the general rule is, write as many as you need until you can see the pattern. And so this would be the expansion of the expression 2 times n factorial. All right, let's try one more example. This time, let's kind of do it in reverse. So you saw what happened when we were on the other page, when we were trying to simplify. Let's go to those. How we wrote things out and then did canceling. So what I'm doing is giving you it after things were canceled, and I want you to come up with the original factorial. So we look at this, and obviously the bottom, well, that's 4 factorial. So that's easy enough. But the top is not a factorial. But what if I kept going, and I did 10 times 9 times 8 times 7, all the way down to 1. Then on the top, that would be 14 factorial. Well, I can't just multiply some extra stuff on the top of a fraction. That's changing the value. But if I multiplied the exact same thing on the bottom of the fraction, now I haven't changed the value of the fraction. It just looks different, it's more complicated, but it has the same value, because all that stuff in green would cancel out and reduce down to 1. All right, so now I can rewrite this as 14 factorial on top, 4 factorial times 10 factorial on the bottom. Okay, so that's a basic intro to factorials. And then you can find your assignments starting on page 17 in section 1A of the textbook.